not very difficult, it's actually a very easy lesson. It's mostly, it's entirely really just the calculator. We want to have a look at series, using the calculator to calculate a series. So, I hope you remember the difference between a sequence and a series. The series, what's the key difference? Do you remember? Yeah. Series is the sum. So, like if I had something like this, one example, 1 plus 4 plus 9 plus 16. That's the series. It's the sum of a sequence. Sum of a sequence. Now what I want to show you this morning is some notation. So you could actually write this series as follows. This symbol here, which I'm sure people have seen before, sum. And if we think about a formula that represents this sequence, what would be the formula for this sequence? Square number. So yeah, what would be the formula? Square what? N squared. N squared, yeah. And n starts at 1 and finishes at what? Yeah, now see, this confuses people. Some say 16, some say 4. If you think about it, it's actually 4, because what we have here is 1 squared, 2 squared, 3 squared, and 4 squared. So we have gone from 1 to 4. Okay? So we can add this up on the calculator. So that's 30, is it? That's 30, isn't it? Yeah. Okay, so here's another one. Example. Let's say sum. And let's start at a bigger number. Let's say we start at 2 and we'll go to 10, and the sequence is 2n. So what's the first term here? 4. Because we're starting at 2 this time. So 2 2s, 4. So it's 4, 8, no, yeah, sorry. 4, 6, 8, 10, 12, 14, 16. Where am I stopping, by the way? Yeah, 20. Because the last one is 2 10s. Stopping at 20. And we can add these up on the calculator. Yeah. Okay, so I will give you a short one. I want you to use your calculator to calculate this, please. We'll start you at 0. And we'll go up to 4. And we'll say 2 power n. So using your calculator, give me that, please. How's my battery, actually? It's all right. Yeah, 1 plus 2, yeah, plus 4, plus 8, and so on. Or 21? 31, yeah. So it should be 2 power 0, which is 1, 2 power 1, which is 2, 2 power 2, which is 4, 2 power 3, which is 8, and 2 power 4, which is 16, and this totals up to 31, we said. Yeah. Okay, I am going to give you a few more sequences, and I want you to calculate them. Can I scroll down? Yeah. So,
How can I use the calculator to...
No, I'll show you that in a minute. Yeah. Oh, actually, no, I'll show you now. So, before we continue, I actually want to show you how you can use your calculator to do this really quickly. So, let's take something like sum let's say 0 to 5 n factorial. Yeah, now, you can actually type this in on the calculator. If you can all look, please. You see there's a button here, shift sum on the log button. Now, instead of using the letter n, they use the letter x. So x goes from 0 to 5, and in here the formula is x, which is alpha x factorial. Where is my factorial here on this calculator? Where's my factorial on this one? It's up the top, isn't it? Shift factorial. Okay. Yep. So, in one press I can get the answer. The calculator can do it. Maybe not this one. No, sorry. So this is convenient. It's obviously convenient. Oh, I don't think this one can. Sorry. I don't think so. It's only the silver one. Oh, I just kept. You might have to just press left and right a little bit to get it. No, just keep pressing one of them. I will. Just keep pressing right or left. Yeah.
Or maybe up and down.
Or yeah.
Would this apply to even things more complicated, like x4 plus 1 or something like that?
Yeah, you could. So, like for example, if you had 0 to 10, let's say 2n plus 1. You mean something like this?
Yeah.
Or even 2n squared plus 1. Yeah, that works too. So I'll just have to change it a little bit. This is now a 10. This is a 2 squared. Whoa. The heck? Okay. 781. Not this calculator, sorry.
There is no function.
Yeah. So watch, on this calculator it's shift and this button here.
Log.
Yeah. Which calculator do you have? No, I don't think this one can, sorry. So if you don't have this calculator, the only way to do it is bit by bit. So you write 2 times 0 squared plus 1 plus, what's the next one? 2 times 1 squared plus 1, and so on. So on and so on. Yeah? Okay, let me give you some sequences to calculate. So, I want you to do these 3 problems for me. You can use your calculator if you like. 0, well, I think, yeah. Not that calculator. Oh, yeah. Get the x. For me, I had to press alpha. What am I saying? Oh, yeah. That's a 0 to 100 and then to 1,000. We'll make it square. I don't even know if the calculator will find these numbers too big. So, those with the Casio 991?
Yeah.
What's the first one then? 55. So if you backspace and change it to 100. No, wait, this isn't 55. Yeah, okay, thank you. 385. All right, the next one? 338350. Okay, and now what about the next one? Math error? It's about 65 million, is it?
No, I don't have a good calculator.
Calculating. A dude with graphing calculator, you should be flying through these.
I don't know how to use it. So I'll figure it out.
Okay. Hang on. I can't hear her. Say again. Okay. Yeah. 5. Okay. All right. So, what word would you describe this sequence? Remember we had some vocabulary yesterday? Yeah. It has to, well, it has to count from 1 to 1,000 each time squaring and adding up. So it's as if it did 1 squared, 2 squared, 3 squared, and totals the 1,000 numbers. What word describes this sequence?
Periodic.
No. This one's not periodic.
The divergent.
Divergent. So you can describe this series as divergent. Let's have a look at another one. So let's say something like 1 over 2 power n. N equals 0. And again, let's just this time just do, instead of doing 10, 100, 1,000, let's do 1, then we'll do 10, and then we'll do 100. So if I was to only do 1, what would that be? It would be, I think, 3 over 2. I think. Now, if you put in 10, what do you get, please?
How do you do this?
Is it not? 1 plus a half? I want you guys to type in now up to 10, please. What do you get? From 0 to 10, what do we have? 1 point. Okay. And then lastly, up if you were to add the first 100 terms. Probably nearly practically 2. Yeah, okay. I'm sure it'll be nearly 2. No, it must be. What did you get?
Is this 100?
Yeah.
50.5.
I think you mistyped something. I was expecting 2. It's 1 over 2 power n from 0 to 100. Now, what way would you describe this sequence? Convergent. And obviously you can kind of guess what the next example I'm going to do. Periodic one. So let's see what a periodic one would be. You start at 0, and I'll just leave a box here. So this one will be periodic. If I was to put in 1, I'd get 0. If I was to put in 2, I'd get 1. If I was to put in 3, I'd get 0 again. No, that seems, yeah, no, that's right, yeah, 3, I'd get 0 again. So what happens is it keeps switching between the two, because this series will be, if I put in 0, it'd be 1, minus 1, plus 1, minus 1, plus 1, minus 1. So depending on where I stop, if I stop here, what would I get? No, if I stopped for those, 1. And if I was to stop and do the first 4, I'd get 0. Okay? So my point is we can use the language of convergent, divergent, and periodic. Yeah. Right, I'll give you this sequence. 0 and infinity. Now obviously you can't calculate up to infinity on the calculator. But what you could do is you could put in large numbers. Okay, so maybe you could try putting in 10, you could put in 100, then maybe you could put in 1,000. And I want you to look at your answers and tell me if you think this series is convergent or divergent. Okay, so I suggest to try 10, 100, and 1,000. See what you get. Yeah. Yeah. No, you don't need to. What's the question?
So, didn't we take yesterday like a few formulas for divergent, convergent, and periodic? So this also
Formulas?
No, not like formulas, like examples.
Yeah.
Like Wn plus 1.
Yeah.
1 plus 1 over Wn, so on and so forth. And so wouldn't this also apply to them?
What do you mean?
Like,
It just shouldn't
if
matter.
we use the same, if we use like the same, like, WN plus 1, wouldn't it also give us that, 1 plus, 1 over WN, wouldn't that also give us convergent?
No, you could have a sequence which is convergent, but its series is divergent. Yeah.
It doesn't matter.
Oh, sorry. Yeah. We can't start at 0. Yeah, that's quite the problem. What do you get at 10?
2.93.
2.193.
2.928.
Okay, so about 2.9 something. Yeah. Right, the next one? What's the next one?
It's actually supposed to 2.93 because it's 2.938.
So I don't care, because I'm only wanting to see if it's convergent or divergent.
5.18.
5.18. Okay. Does anyone have the 1,000 terms yet? Or is it still calculating? Calculating. Anyways, while we're waiting for that, what do we think? Are we leaning towards convergent or divergent? Yeah. It's divergent. It's divergent. It's divergent even though, which I think is kind of interesting, each term is convergent. This is what we were talking about. So like, look here. If I add up the first term, it's just 1 over 1. If I do the first two, it's 1 over 1 plus 1 over 2. And the next will be 1 over 1 plus 1 over 2 plus 1 over 3. Now, if I continue like this, my total will be divergent.
7.48.
Oh, you got it. Well done. Okay. 7.48. Okay. Whatever. So I think this example is interesting because individually the terms are convergent, but in total they're divergent. It's one of the most common mistakes to make in sequence and series is to think that because the terms are getting smaller, then their total is also convergent. In this case, it's not. Okay, I just give you one more example here. 1 over n squared, n equals, we'll go to 10. Again, yeah, sorry, thank you. And then 1, and we'll go to 100. And this one here will go to infinity. Right, what's the first one there? 1.54. 1.54, okie dokie. Okay, so far, are we thinking this is looking a bit convergent or a bit divergent? Well, it's not really moving that fast, you know. Like the first 10 terms is 1.54. The first 100 terms, it's only slightly more. Now, the real question is, what is it convergent to? So, maybe 2. It's kind of looking like it could perhaps be 2. It's not 2 though. No. To calculate it, it'll take a while to count up to infinity, right? I think we can all agree it would take some time to add 1 over 1, 1 over 2 squared, 1 over 3 squared, and keep going until we get to infinity. Now, just give me a moment and I'll do it. Hang on. Yeah, okay, finished. This will be pi squared over 6. Yeah. Now, I want you to type in pi squared over 6. Really, it really is, yeah. Type in pi squared over 6. You should get something like 1. Yeah. You would never have guessed. Yeah, that's what it's converging to. What was that as a decimal? 1.64. Yeah, 1.64. Converging to. You would never have guessed it's pi squared over 6. You would have guessed it's 2. You know?
Why did you guess it was 5?
I didn't guess, I calculated. Yeah. You can't count infinity in your head? No? Alright. So anyways, my point with this example is we will need a way to properly calculate what the limit is, because we can't really guess, because sometimes the guess is impossibly difficult, like here. So we actually need a method to calculating the limit. And that's what we'll actually have a look at later in the chapter. But for today's lesson, I just want you to be using your calculator. Okay? So, because they're so easy, I just want you to do the column down the right. You see the right-hand column. So like S, T, U, V, W, X, Y, Z. Yeah?
You want us to do all that?
Yeah, because it's just on the calculator.
No, but I was asking to
Yes, the full column. Yeah. Huh? No, I can't. Counting to infinity will take a while. The way to actually calculate this, it's quite difficult, but I just remembered the answer. But you know, there are techniques for calculating these infinite sums. You will learn one of them, but there's actually many different methods for different types of problems.
So if you want to learn more about this infinity
There's many things you could do, yeah. Huh?
if you want to learn more about the infinity calculation.
Yeah, well this one here is perhaps a tiny bit advanced. You might be able to follow it because they'll have most likely several different types of proofs. But I think a lot of them will involve calculus actually. Really. Yeah, so you could Google you could Google like the sum of 1 over n squared. The infinite sum of 1 over n squared. You'll get a few different methods. Yeah?
Could this also apply if we have more than one variable at the same time?
It could. We won't concern ourselves with that. But like, technically you could have a double sum. So, that would be something like n equals 1 to 10, and then m equals 1 to n, and nm. I don't think your calculator could do this, because your calculator only uses variable x for the sum. This is a little bit more advanced. I mean, it's not impossible. So what's happening here is you start at 1 and put here 1 and then sum. Then you put in 2 and sum. And then once you do that 10 times, you get 10 answers from 10 sums. And then you sum those 10.
What are you doing, sir?
Now he's asking if you could have a double variable. We won't have double variables on the course, but it's possible to have double variables. Okay, if you can try those questions, it won't take you long to do, I'm sure.